All right, so number 1 says determine whether the following equation defines y as a function of x, yes or no. So that's just your answer, yes or no. So x equals 8y squared. Excuse me. So we're trying to see, is this a function or not? So first of all, we want to get y by itself. Solve for y, get y by itself. So that means I can divide by 8. That way those cancel. So x divided by 8 equals y squared. Now I'm going to get rid of that squared. The opposite of square is square root. That way the square and the square root cancel each other out. But don't forget, whenever we take the square root, we have to have plus or minus. So don't forget your plus or minus. So I have plus or minus the square root of x divided by 8 equals y. So because I got 2 equations out, so I have y equals positive square root of x divided by 8. I don't have to worry about simplifying that because I don't really care. I just get 2 things out. And the negative square root of x divided by 8. So because I have 2 equations, that means not a function. So more than 1 equation. So our answer is no. And that's it for number 1. Our next one's going to be number 8. And if you guys want to work on your laptops, or if you want to get on these computers on the side and you want to do your like number 1 and number 8 as we're going through it to make sure that you're getting it, you're welcome to do that too. Whatever was going to help you, this is your day. So if you want to get some of these questions knocked out on your review as we're doing it, that's fine too. Or if you just want to sit back and watch, I'm recording it. You just do whatever's best for you. So before I go to number 8, questions on number 1. All right, so going back. We said no, and that's it. So number 1 is no. If we're good on number 1, let's go to number 8. So number 8 says the graph of f is given below. Use the graph to determine the following characteristics. If a solution does not exist, enter DNE. So it asked me to find the domain, range, x-intercept, y-intercept, open intervals where it's increasing, decreasing, constant, minimum, maximum, and then values. Okay, so a lot. So for number 8, domain. Remember, domain goes from left to right. So the left side is going on forever. So because it's going on forever, we're going to have negative infinity. For our infinities, we're always going to use parentheses. So this side is going on forever. So that's negative infinity. The right side of our graph, it does this little loop or whatever, but then the right side of our graph is also going this way forever. So nothing's stopping it. So that's going to be positive infinity. Again, we can never reach infinity, so we're going to use parentheses for that one. So negative to positive infinity is for our domain. Reading our graph from left will be negative infinity, right will be positive infinity. Our range. So the bottom of our graph does not, even this thing goes on forever, this thing goes up, but nothing goes past this point right here. So because nothing goes past this point, this is our lowest y value. So this y value is going to be negative 1. There is a point there, so that point is going to be a closed circle. So a closed circle means a square bracket. So a square bracket at negative 1. and then comma. This does whatever it wants to do, but this is going to go up forever. So because that goes up forever, that's going to be positive infinity. We could never reach infinity, so we're going to use parentheses. Oops, I didn't mean to press enter. Those two are done. So pausing for a second. Questions on domain and range? So the next thing says our x-intercept. So write your answer as a list of integers or decimal numbers. So just writing the numbers. So where does it cross my x-axis? So here's my x-axis. It crosses it right here. This value is going to be positive 1. So positive 1's an answer, comma. It also crosses my x-axis right here, which is that positive 3. So 1 and 3 are my two x-intercepts. So 1 and 3 are the two places where it crosses my x-axis. While I'm here, my y-intercept, so where does it touch my y-axis? Right here, the only spot, which is this positive 3. So my x-intercepts are 1 and 3. My y-intercepts, just positive 3. So before we go to the next part, questions on this one? All right, so next is open intervals. Open intervals tell me, I wish I could like write. I don't know if I can. Anyone know a way I can like write on my screen? Okay, whatever. All right, so open intervals means that it's going to be like open circles. Open circles means it's going to be parentheses. So open intervals is always parentheses for these. And it tells you that in the problem. Open intervals means parentheses. So where it's increasing. So this graph is being constant right here. It's flatlining right here. Then it's dipping down, so that's decreasing. But then from here, which is my 2 value, on, it goes up. So this piece right here, and this piece, so from this piece right here over, this is going to be where it's going upward. It's increasing. So whenever it asks you is where it's increasing, that means your x values. So my x values from 2 and everything over, so from 2 to infinity, it's going upward, it's increasing. Again, open interval, so always using parentheses from 2 to infinity. Next one's decreasing. So from here on, it's going upward, it's increasing. This one's staying constant, but this piece is decreasing. So starting right here, it dips down. So this x value is -1. So starting at -1. So starting right here, x value is -1, it goes down, and then it's going down, going down, going down, and then boom, at 2 it goes up. So then it's stopping decreasing, it stops decreasing at 2. So from -1 to 2. Last piece, which one is it constant? So constant means flatlining. So this is the piece that's flatlining, it's constant. This is going on forever to the left, so negative infinity. So negative infinity. And then it stops flatlining, it stops staying constant, it starts decreasing right here. This value is -1. So from negative infinity to -1. It's flatlining, it's constant. Again, open intervals, so we're going to use parentheses. So questions on increasing, decreasing, constant. All right, so the next two are minimum and maximum. So minimum is the low point. So it says at which x value for which f has a relative minimum. So let's find the minimum, let's find the low point. So boom, right here, this is our low point, this is our minimum, this is the bottom point. So this bottom point would be at -1, 2. So this, I'm sorry, at 2, -1, 2, -1. Sorry, got dyslexic for a second. 2, -1. So this x value is going to be 2. the y value is going to be -1. So the x value, which is +2, the value of f, which is our y value of the minimum, is -1. It's always going to ask you x and then y. So 2 and then -1. I had an idea, but I'll finish how we're doing it, and then I'll go back. So 2, -1 was our minimum. Same thing for our maximum. Our maximum is our high point. But this flat lines, and then it goes down, and then it just goes up forever. So there's no peak here. There's no high point. Everything just goes up forever. So there is no maximum. So our maximum is going to be d any for both. There's no maximum. It does not exist. The next one says f of -6. So when our x value is -6, what's our y value? So when x is -6, which is right here, boom, here's my graph. So what is this y value? +8. So -6, +8. So -6, +8. Almost done. This one says same thing, the opposite. It says what's the x value for which our f of x, which is y. So when y is -1, what's x? So let's see, when y is -1, y is -1, which is right here. Here's my graph. This point right here has an x value of 2. So 2, -1. When y is -1, x is +2. Last thing says even, odd, or neither. So for even, we know that it has y-axis symmetry. So if I fold it hot dog style, so same thing if I fold it like this, but they don't match. So that's not going to work. X-axis symmetry would be folding it this way, not going to work. Odd means it has origin symmetry. So if I fold it both ways, so X and Y, so it'd be the same thing in this quadrant, same thing in this quadrant. There's no symmetry here. So because there's no symmetry, it's like a wonky graph, it's going to be neither. And then we're done. My thought was maybe to kind of help number 8. I'm not very good at drawing, but maybe this will help. All right, so there's our graph. So just kind of recapping real quick. Our domain, we said it went on forever to the left, so -infinity, on forever to the right, so -infinity, +infinity. Our range stopped down here at -1, so there's nothing went past that -1, but then it went up forever to infinity. This is where it was constant. This is where it was decreasing. This one is where it was increasing. So 1 and 3. So this was an x-intercept. This one was another x-intercept. Our y-intercept was at 3. I made it at 2 on accident. So then here, y-intercept is at 3. This was our minimum. And then what was it? 2, -6. Intercept, y-intercept. -6. And then -1. So -6. This was our point, which had a y value of -6.8. So xy. And then the last thing, this was our 2, -1. So xy. So that kind of maybe labels, I don't know if it helps, I hope it helps, kind of labels everything virtually on the graph. So is there anything to do to help you with number 8, kind of having everything labeled now? Questions, comments, concerns on number 8? You guys feel okay? Can I go to number 13? You're like so hard to read. You're okay? Can I go to number 13 or okay on number 8?
You're good.
Okay, thank you. Sometimes I feel like I try to make this so easy that I like try too hard. But it's hard because like you guys are just... All right, number 13. I got a lot of emails about piecewise functions. This is a good one to go over. So number 13 says graph the piecewise function, determine its range, and then evaluate f of -3. All right, so for number 13, I have f of x equals -4x minus 2. And what I'll do is I'm recording this now, but I'll also send out a PDF of my notes that I have here. I'll just scan it and get a PDF, and I'll send this out to you too. So x is less than or equal to 0, and then 2x plus 3 when x is greater than 0. So I have 2 pieces of my graph. So I need to figure out how I can graph these 2 pieces. So my first piece is -4x minus 2. And it says when x is less than or equal to 0. I always want to do that endpoint. That tells me the end of the graph. So always do the 0. So if I do -4 times 0 minus 2, that would just give me -2. It says or equals, so I know that's going to be a closed circle there. And then any other point that satisfies the condition that x is less than or equal to 0. So anything less than or equal to 0. So -1. So -4 times -1 minus 2, which would give me 4 minus 2, which is 2. So I'm going to draw it on my paper, but I'll also go back to the computer as well. So 0, -2 is a closed circle. And then the other piece is over -1, up +2. So there's my second point. So connecting the dots, there's the first piece of my graph. So I'm going to do the same thing for the next piece, which is 2x + 3. And this is for when x is greater than 0. So again, I want to make sure to have that endpoint, so I'm going to plug in 0. So 2 times 0 plus 3, which is 3. Because it's just less than, it's not or equals to, this is going to be an open circle. So my other piece is at 0, 3, open circle. And then any other number that satisfies the condition, that's any other number that's greater than 0. So let's do +1. So 2 times +1 plus 3, which will give me 2 plus 3, which is 5. So +1 up 5. So 1, 2, 3, 4, 5. So connecting those dots, there's my next piece. So those are my two pieces. Are we okay so far? All right. The graphs on these are like super finicky. So let's pause right there and let's go to graph it. Oops. All right, so we set a closed circle at 0, -2 for the first piece, and the other point was -1, 2. So from this point to -1 up 2. So there's the first piece, just like I graphed it on my paper. The second piece is an open circle at 0, 3. And then going from that 0, 3 to my next point, which is 1, 5. I don't know why it's... There we go. So those are my two pieces. Questions on how I graphed it on the computer or anything? So now looking at the range. So now that I have this, the range is my y values. So if this is at -2 and then it goes up, this is going to go up. So nothing's going to go past that -2. Closed circle, so square bracket at -2. And then it goes up forever. So comma infinity. Even though it kind of jumps right here, there's not a gap because the -2 will take the place of the open circle, and then it goes up forever. So -2 to infinity. The last piece is -3. So f of -3. So let me show you here. So range, we said was -2 to infinity. And then it says f of -3. So our x value is -3. So -3 will satisfy this condition. So when x is less than or equal to 0. So I want to plug it into this first piece. So, which is x is less than or equal to 0. So plug into -4x minus 2. So I have -4 times -3 minus 2. So I have 12 minus 2, which is 10. So 10 should be that answer. If you also look at the graph, so let's go back for a second, look at the graph. If you plug in -3, here's my graph, which hits at 10. So that's another way to do it. You can either do it graphically or plugging it in. So either way, you get 10. And that's it. So how could I help you with number 13? Talking about graphs with the software. Daniel, can I call you out a little bit? I mean, I'm asking about it. So Daniel sent me an email of a question, which was super good. I got to answer, so that's what I was going to tell you, but I might as well tell you one. Where he graphed it, but the x-intercept was 2/3. But I asked the guy who programmed it, because has like way better like the deeper stuff, and he said just like what you said is you can only graph 0.5s. You can only graph 0.5. So if you come across a question on the homework, the point in that problem was, okay, if you can't graph 2/3, pick another point. So pick any other point to plot. So you can plot any 2 points. So that one wasn't like a nice, pretty number. Plug in any other number to get like a prettier. That was his response. And I included the course lead and the old course lead, and so there's like 2 course leads, and they said the same thing. So I was hoping they would be like, oh, you're right, let's just take this one out. So does that answer your question though? I'll email you back, but I just got that email. I think I'm probably not the answer you want, but that's what it is. So if you come across one that's ugly to graph, just find another point. That should be it. They should all have points that are pretty enough to graph. Pretty as in like whole numbers. All right, so speaking of graphing, speaking of anything else, number 13. So the next one's going to be 17. So number 17 says, write the point slope form equation of the line that passes the given points. Also write the equation in slope intercept form. So number 17, I have -19, -9, and we have the point 12, 14. Putting this in point slope and slope intercept. So I have 2 points. I can label this as x1, y1. Label this one as x2, y2. Because we need to have our slope to put this in point slope form. So our slope, which is our m value, is going to be y2 minus y1 all over x2 minus x1. So we have 14 minus -9 all over 12 minus -19. Y2, which is 14, minus -9, which is y1, and 12 minus -19. 2 negatives can become a positive, so if you want to write it as 14 plus 9 all over 12 plus 19, that's fine too. So in our calculator, 14 plus 9 is 23 all over 12 plus 19, which is 31. I don't think that they can be simplified, but just to kind of remind you, showing you how you can do it on your calculator, 23 divided by 31 equals ugly decimal. If you hit your math button into a fraction, so press enter, it still gives you 21 over 31, so, or 23 over 31, which is ugly, not simplifiable, so just leave it. So then putting this in point slope, so point slope is y minus y1 equals m times x minus x1. So y minus y1, which is -9, we could use either point, doesn't matter, equals m, which is 23 over 31, x minus x1, which is -19, which is perfect. But our last step is those 2 negatives become a positive. So y plus 9 equals 23 over 31, x plus 19. And that's it for point slope form. So just like mine, mine's super ugly, but it's okay. Don't freak out. Don't think that you're wrong. All right, and then just putting this equation in slope-intercept form. So I can distribute that slope. Remember, your slope-intercept form is y equals mx plus b. So you're basically just trying to get y equals. So y plus 9 equals 23 over 31x plus 23 over 31 times 19. So which 19 is like 19 over 1. So I can multiply top times top, bottom times bottom. So 23 times 19, top times top, which would give us 437 over 31 times 1, which is just 31. I'm going to see if I can simplify that. So 437 divided by 31, ugly decimal, hitting my math button into a fraction, so press enter. Same thing, so it's still ugly. But then our last step is to get y by itself, so let's subtract 9 from both sides. Use a different color. I want to do this the way that you would do this. Would you guys do this by hand, or would you do this in your calculator? The 437 divided by 31 minus 9. Calculator? Okay. So 437 in parentheses divided by 31, and then minus 9 equals, and then turning your math button into a fraction, so press enter. One more time, press enter. Boom, there's your answer. So y equals 23 over 31x, and then this 137 over 31 minus 9, we said was positive 158 over 31. So that is your slope-intercept form. Yeah, calculator is way easier. So question, so make sure that you know your slope formula, which is this one. Make sure you know your point slope form, and make sure you know your slope-intercept form. So make sure you know those formulas for the test.
Yeah, if I was to have done that by hand, I got that crazy number. I just
Xander, I know you well enough to know that yes, you would probably erase it and then start. Yeah, looks super ugly. So if you get on the test and it looks super ugly, think that you're doing it right, because the one we did together was super ugly. So you have confidence in that, I guess. All right, let's put it in. So point slope was y plus 9 equals 23 over 31 x plus 19. Oops, I didn't mean to do that. And then y equals 23 over 31 x plus 158 over 31. I'm not going to lie, if I got this on a test, I would probably think it's wrong too. But again, we're doing it together, and it's super similar to what's on the test, and it's super ugly. So if you get a super ugly answer on the test, you're like, okay, well, that looks similar to what we did on the review, so you're probably right. So how could I help you with 17 before we go to 18? Questions on 17 before 18? Can I go? All right, so 18 says determine the equation that satisfies the given conditions. It's parallel to y equals 3x plus 8 and passes through negative 3 minus 8 in point slope and slope intercept. All right, so number 18, it says that it's parallel to y equals 3x plus 8 and then passes through negative 3, negative 8. All right, so parallel we know means it has the same slope. If yours says perpendicular, remember that perpendicular means opposite sign, so one's positive, one's negative. Reciprocal, which means you're going to flip your fraction. Slopes. So thankfully, this one is like, they're actually like halfway nice for once. This one's in y equals mx plus b form. So I can just look at it and say, okay, this slope is 3. So that means our parallel slope is the same, which is also 3. So our slope is going to be 3. And they give us the point -3, -8. So they give us an x1, y1. So I can plug this into my point slope form. Which again, point slope is y minus y1 equals m times x minus x1. So y minus y1, which is -8, equals m, which is 3, x minus x1, which is -3. The only thing with point slope that we have to simplify are those two negatives become positives. So y plus 8 equals 3 times x plus 3, which, shoot, this looks like so nice compared to that last one. And then lastly, putting this into slope-intercept form. Which we know slope-intercept form is y equals mx plus b. So we're just trying to get y equals. We're just trying to get y by itself. So we can distribute that 3. So y plus 8 equals 3x plus 9. And then getting y by itself, I could subtract 8 from both sides. So y equals 3x plus 1. Done. So that is number 18. Next one's 23. Before we go to 23, questions on 18. Can I go to the next one? All right, so let's put in 18 and then we'll go to 23. All right, so we said y plus 8 equals 3 times x plus 3. And then y equals 3x plus 1. All right, perfect. So number 18. So the next one we said was 23. All right, so this is 3.5, so that transformation section. So use parent function, f of x equals x squared, so we know it's going to have that x squared shape. In our calculator, if you plug in x squared, you know it's going to be a parabola, so it's going to have that u shape. Also, it kind of helps us because it has a u right here, so we know this is going to be the shape it's going to be. And transformation techniques to graph g of x, which is 2 times x minus 3 squared minus 4. Indicate the transformations. So if we have g of x, all right, so just so that we kind of can see where I'm coming from. All right, so that minus 4 is subtracting 4, so we know it's going to be a shift. It's on the outside, so it's affecting our y values. Y values are up and down, so that means -4 means we're going to shift it down. 4 units. So because we're subtracting 4, that means it's going to go down 4 units. Next, I have x minus 3 squared. So that minus 3 to our x. Again, it's adding or subtracting, so I know it's going to be a shift. It's literally happening to x, so x minus 3. So that means it's going to be left or right. Our left or rights are our weird ones, so it's opposite of what we think. So in my head, negative would be to the left. So that means it's going to go to the right. So shift right 3 units. This x squared is part of my parent function, so that just tells me the shape, so it's not a transformation. And then lastly, I have this 2 out front. So numbers that are being multiplied out front are going to be stretches or shrinks. It's a whole number, so I know it's going to be a stretch. It is outside of x. It's outside the parentheses, so I know it's going to be vertical because it's affecting our y values. So vertical, stretch by a factor of 2. So that's all that's happening to our x squared. So 2 is going to be a vertical stretch by 2. The minus 3 is shifting it right 3, and then the negative 4 is shifting it down 4. And if you get confused, especially with like the left, right, up, down things, when you graph it on your calculator too, you kind of can see, is it going up or down, or is it going left or right? So putting these answers, are we good with the paper? Can I go to the screen? All right, so we said a vertical stretch by a factor of 2, right 3 units, and then down 4. So now it says to graph. So in my calculator, I can just plug in 2 times x, y equals 2 in parentheses x, which is next to our alphabet, minus 3, closing my parentheses, hitting the squared button, which is diagonal to the 7, and then minus 4. 2 times x minus 3 squared minus 4. And then pressing graph. So there's my graph. That bottom piece, I know if I were to also graph my x squared, which is my parent function, going to my graph. So this vertex was at 0, 0, and then we shifted it down 4 and then right 3. So without even like really having to figure that out, I know that it's going to be at positive 3, negative 4. So real quick, let's go to the graph. So positive 3, negative 4. And then just finding any other point. So I can go to my table. Let me show you, sorry. So on my table, it doesn't matter. So like, let's say 1, 4 is a good one. Remember, my y2 was my parent function. So my y1 is 1, 4, just so I have another point on my graph from my table. So over 1, up 4. And so there's my graph, and there's my transformations. So is there anything I do to help you with number 23? Our next one's 27. Can I go there? All right, so 27 says to find the domain of the given function and then enter our answer as interval notation. So interval notation, remember, is like brackets, parentheses from one number to another number. So it says g of x equals the square root of 6x plus 5. So we had two kind of things that we looked at so far. The two things we looked at so far for domain is fractions, because for a fraction we know the denominator cannot be 0. And we looked at radicals. So for a radical, we said whatever we're taking the square root of has to be positive. So if it's negative, then it's imaginary. We can't graph imaginary. So whatever we're taking the square root of, which in this case is 6x plus 5, has to be positive, which positive means greater than or equal to 0. Oops, why did I change? Sorry. 6x plus 5 is greater than or equal to 0. So remember, for radicals, whatever we're taking the square root of is going to be greater than or equal to 0. And then the other thing was fractions. So for fractions, the denominator cannot be 0. Those were the two things that we looked at for domain. Anything else is fine. I'm not trying to be rude by eating, but I don't feel good, so I think I might need to eat a little something. So is it okay if I just have this? Sorry, I don't mean to be rude, but I also don't want to pass out. Anyone want a pretzel? All right. Getting x by itself. We're going to subtract 5 from both sides. So that'll give us 6x is greater than or equal to negative 5. And then dividing both sides by 6. So x is greater than or equal to negative 5, 6, which cannot be simplified. So that's our answer. We just need to put that interval notation. So remember, for interval notation, we're going to use our number line because that kind of helps us see our interval. Our number line goes from negative to positive infinity. We're talking about negative 5 over 6. We're saying x is greater than, bless you. You're welcome. Greater than, so everything on the right-hand side. Or equals to, so that means square bracket or closed circle, either way. So then reading my graph from left to right, closed circle, so square bracket at negative 5 over 6, and it's going on forever to the right, so towards infinity. For infinities, we always have parentheses. And that's it. So that would be our answer for number 27. So how can I help you with number 27? This is our halfway point. Are we good? We have 10 minutes. You just want to keep going while we're kind of rolling? Yeah, that's what I kind of figured. The next one's kind of might take a little longer anyway, so that's kind of maybe good. All right, questions on 27. All right, putting it in, bracket, -5/6, comma, infinity. All right, if we're good on 27, let's go to 29. The 29s are same thing. There you go. This time we have a fraction. So this was our other thing that we talked about. So 29 says give the domain of the given function, write our answer in interval notation. So f of x equals x minus 2 all over x squared plus 5x plus 4. So we said for fractions that our denominator cannot be 0. So that means our denominator here cannot be 0. So x squared plus 5 plus 4 cannot be 0. Plus 5x, x squared plus 5x plus 4 cannot be 0. Factoring always finds a way to show back up. Here it is again. So this is a quadratic, it's x squared. So we need to solve this thing. It's in standard form, so I can try to factor. There's no GCF. Yeah, 4 times 1, thank you. So A is 1, B is 5, C is 4. Looking for two numbers that multiply together to give me A times C, which is 4. Same two numbers to add together to give me B, which is 5. Said 4 times 1. 4 times 1 is 4. 4 plus 1 is 5. Thankfully, our A value is 1, so we can use our shortcut. Our shortcut says we go straight to our two factors. Set not equal to 0. Variables x, and our blanks positive 4, positive 1. So x plus 4 times x plus 1. Yeah, this one was kind of easy to factor. So if you wanted to skip green steps, that's fine. You can just go right to your factors if you want, if you can. I get like on the test where I'm like, don't want to skip any little tiny step because that like messes up everything. So I do like every single step. All right. So setting each factor not equal to 0. So x plus 4 cannot equal 0. X plus 1 cannot equal 0. Solving for x, so subtracting 4 from both sides. Subtracting 1 from both sides. So we get x can't equal -4 and it can't equal -1. Any other number's fine, just not -4 or -1. So just like the previous problem, I'm going to use my number line to help me write this in interval notation. We said it can't equal -4 or -1. Remember, it's in order from least to greatest, so -4 goes on the left side, -1 goes on the right side. So open circles there because it cannot equal those two numbers, but it could be anything else. So anything on the left side, anything in the middle, anything on the right side. It's fair game. So then writing this in interval notation, going from left to right, starting at -infinity, always parenthesis for -infinity, stopping at -4, open circle, so parenthesis. Our next piece, so use our U to unite the pieces together, because it could be in this piece, or this piece, or this piece, so that U means our or. So from -4, -1, from -4 to -1, open circle, so parentheses. And then our last piece, so another U, -1, open circle, so parenthesis, to positive infinity. always use parentheses for those. And boom, there's our answer for number 29. How could I help you with 29?
When it pop up, you know, like sometimes you're writing in the problem on the computer when you do this stuff.
Yeah.
It'll pop up like something red will say.
Oh, yeah, yeah, yeah.
Pop up if you don't put the user.
Yeah, if you don't put the use, it'll say like syntax error or whatever it says. I'll show you. Oops. See, it says syntax incomplete. So go into my interval, putting in U. It's still saying that, but it's because I'm not done.
You forgot the negative.
Oh, thank you. Is that good? Boom. Yeah, so if you forget the use, if you didn't put the use in, it would say like invalid interval notation. Even if you put commas, I know a lot of people try to put commas, it will tell you that on there. Just leave it as your use. Thank you for asking that. All right, other questions on 29 before we go to 30? 30 might be our last one. Ready? Can I go? All right, 30. All right, so number 30 says give f and g as defined below. Determine f plus g, f minus g, f times g, f divided by g. Using interval notation, report the domain for each. So thankfully these aren't bad ones. So we have f and g. First, let's find f plus g. So we're going to take our f function, which is x squared minus 3x. We're going to add our g function, which is x plus 11. Notice I put them in parentheses because you want to leave those together. There's nothing outside this first set of parentheses to distribute, so it's going to stay x squared minus 3x. For the second set of parentheses, if I distribute that positive, it's going to stay plus x plus 11. But then I can combine my like terms. Negative 3x plus 1x. So we get x squared, negative 3x plus 1x should give us negative 2x plus 11. These are not like terms, so I cannot combine it further. So that's f plus g. Thankfully, there's no fractions, there's no radicals, so no problems. So then our domain is just no problem. So everything. So negative infinity to positive infinity. So that's kind of nice, at least. Some of these I know get like super intense on the homework. So same thing for f minus g. So I have f, which is x squared minus 3x, minus our g, which is x plus 11. Nothing outside of our first set of parentheses to distribute, so it'll stay x squared minus 3x. But don't forget, distribute this negative. So it'll be negative x minus 11. So then here, when you combine like terms, you get x squared, negative 3x minus 1x, which is negative 4x, minus 11. Again, for our domain, no fractions, no radicals, so no problems. So our domain is no problem, so everything. So negative infinity to positive infinity. Almost done. F times g. So x squared minus 3x times g, which is x plus 11. Let's distribute. So x squared times x, which is x cubed. X squared times 11, which is plus 11x squared. And then negative 3x times everything. So negative 3x times x, which is negative 3x squared. Negative 3x times positive 11, which is negative 33x. Combining our like terms. So we get x cubed, 11x squared minus 3x squared is positive 8x squared, minus 33x. These are not like terms, so I cannot combine it. So that's it. Again, thankfully, no fractions, no radicals, so no problems. So our domain is going to stay no problems so far, negative infinity to positive infinity. Last one, I know we're getting close. So f divided by g. So I have x squared minus 3x divided by x plus 11. I can't do anything to like simplify this. Even if you were to factor the top and take out an x, it'd be x times x minus 3 over x plus 11. Nothing cancels, so you can just leave it. But what does happen here is now there's a fraction. So our domain is different. So it's a domain, it's a fraction. So our denominator cannot be 0. So that means x plus 11 cannot be 0. Getting x by itself, we could subtract 11 from both sides. So that means x cannot be 11, sorry. So on our number line, from negative infinity to positive infinity, cannot be negative 11, but it could be anything else on the left side or on the right side. So from negative infinity to negative 11, open circle, so parenthesis, or, so don't forget your u, negative 11 to positive infinity. Sorry, I was trying to get done because it is 12:17. So that was our last one. We're going to stop right there. I'm going to put this into the computer. Before I do that, questions, comments, concerns? Yeah.
I think I see what it's like. When you like distribute the X out, will it mark it wrong or?
This one or this one? No, I think either one will be right.
All right.
Let's try it. So we said X. Bye. Thank you. If you have any questions, please let me know. Just put this in real quick. And then x squared minus 4x minus 11. Oh. We'll pick up where we left off last time, or next time. Bye. Thank you. See ya. You want to put in this one or you want to put in the other one? This one?
Are the other two tests, not test 2, but test 3 and 4, are they similar to like the graphing and stuff like that, or do they all connect?
Yeah, test 3 is like all graphing, but test 4, no. Test 4 is logs, which we'll usually do really good on test 4.
Just trying to prepare.
So why, do you like the graphing or do you not like the graphing?
I did that.
Yeah, so one more. No one likes test 3, sorry, because it's just all graphing, and then we'll be done graphing.
Okay.
Bye. Yeah, there you go. Nothing canceled, so you don't have to. But I believe, let me see if it'll let me go back. And if you did x minus 3, I believe it would take this as well. Yeah, so either way, it's fine.
I know.
Yep.
Thank you.
You're welcome. No, thank you. See you guys. Thank you very much.